called the Worldwide Universities Network. It's a network of 18 research-intensive universities across the world that get together precisely to do collaborative work on 4 global themes. The global challenges are responding to climate change, non-communicable diseases in public health, understanding cultures, and the 4th one is the globalisation of higher education and research. So the uprising of things like MOOCs, massive open online courses, and new technologies, and the issues around student debt and access and equity in higher education. The second network is called the Matariki Network of Universities. That's 7 universities around the world. And the purpose of that network is to share experiences on the student experience and to enhance and improve the student experience. So we use that network specifically to grow study abroad opportunities for our students and to review each other's practices for student accommodation and student welfare and career advice, and to help each other out with any student problems we might have. We have many agreements with many international partners, including partners in Thailand, and indeed 20 years ago when I was here at PSU teaching computer science, that was part of an agreement between our university and PSU. One thing we do at our university is think about being in the zone. So instead of thinking, we tend cognitively to think of the world in a very horizontal way, a very east-west kind of paradigm. but our university, we're very focused on being in the zone. And the time zone I put there is a time zone that's plus or minus 1 hour from Perth. And that time zone has 60% of the world's population. That time zone is the time zone that is growing economically the fastest in the whole world. And that time zone is where all the political power is shifting. So using modern technologies, we're very keen to engage in this time zone, particularly looking at things like collaborative course delivery, engaging with industries, etc., because we're all working at the same time every day. And then we're all sleeping at the same time every night. And this is our Chancellor, Michael Cheney, who's been a strong supporter of In the Zone. And every year we have a major In the Zone conference at our university to bring together economic, political and academic leaders to discuss issues around our zone. These are the areas of research that our university is most strong in. And you'll see plant sciences is one of our big areas. But also geosciences, because there's a lot of geology, energy, minerals work, public health, occupational health, biochemistry, molecular biology, etc. I'll talk about some of these as we go on. As I mentioned, we're one of the group of 8 universities. The other universities are in capital cities in Australia, and we're quite a long way away from the rest of them. We were established in 1911. And we're a comprehensive university, not specialist but comprehensive. We have 9 faculties and then 3 major institutes and 3 major affiliated medical institutes. So our faculties range from architecture, arts, business, education, engineering, law, sciences, medicine and agriculture. And all of those faculties are research intensive. But I'll be spending most of my time today talking about some of science. The institutes we have are designed to be cross-cutting and problem-focused. So, for example, we have an Energy and Minerals Institute that aligns with the major resource sector of Western Australia, and that looks at all issues relating to energy and minerals production. So it includes the business school. It includes the arts faculty, where we have a very strong group working on rock art and the preservation of indigenous artwork. The agriculture faculty, for example, is also cross-cutting. It includes economists looking at agricultural resources. It includes the medical faculty looking at nutrition and health. And the Oceans Institute is around ocean science, marine science, oceans engineering, environmental engineering, conservation, management, etc. So we love science. We're a very strongly science-based university. We're rated at above world standard in over 40 fields of research in science. 40 fields of research and 80% of these are scientific. And 50% of our undergraduates are studying science. And 70% of our postgraduates are studying science. So we're a very strongly science-based university. In one particular area, and this is courtesy of our Nobel Prize, I have to say, but nevertheless, we're ranked 33rd in the world and first in Australia in life and agricultural sciences, and second in Australia in chemistry. We, in science alone, publish approximately 1,000 papers a year, and the university as a whole publishes about 3,500, 4,000 papers a year. And they're highly cited, of course, but we have 15 of our staff are actually on the highly cited list, so in the top 250 most highly cited scientists in the world in their area. The Faculty of Science itself has 30 undergraduate science majors, and we bring multidisciplinary groups together to tackle various problems, as I'll show you shortly. So here this is Perth. This is what Perth looks like. It's a little bit bigger than Hatchai. And it's a beautiful city, I have to say. So Western Australia is Australia's largest state. Almost everybody lives in one city, Perth. And the rest of the country is quite remote and isolated. It's the capital city, and it's renowned for biodiversity, and it's really one of Australasia's economic powerhouses. Plus we have nice beaches and things, right? So the biological diversity, the southwest of Australia is identified as one of the world's top 25 biodiversity hotspots. And we still have a lot of plants and animals that have yet to be classified. Every week there are new species being identified. Part of this is because Australia has been remote from the rest of the world for millions and millions of years, and the plants and animals are very different from the rest of the world. So, some of the images at the top there, that's an image of the Pinnacles just north of Perth. These are, it's an old fossilised forest that was submerged under the ocean and has now come back as it's like a park on Mars, really. No trees there, it's all fossils. And then down the bottom there are some images of some stromatolites, which are the oldest known organisms on the planet. Australia's southwest is very biodiverse, over 300,000 kilometres with over 1,500 plant species and many endemic mammals, including the numbat. We have a very rich marine environment, so over 13,500 kilometres of coastline, and this varies from temperate waters in the south to tropical waters in the north. With the Ningaloo Reef, one of the world's largest coral reefs and virtually untouched, unlike the Great Barrier Reef on the other side of the country. You can see why we have established an Oceans Institute, because there's so much work to do there. And Shark Bay, up near the Ningaloo Reef, is a World Heritage listed spot. As I mentioned before, most of Western Australia is empty of population, but it's full of mineral and energy resources. So a strength of our university, and aligned with the local economy, is minerals, mining, and energy. So some of the minerals there you can see listed. We also have a large agricultural industry, probably quite different from yours because we are a dryland agriculture and you are very tropical and wet. So ours is mostly focused on wheat, wool, beef and lamb. And our soils range from subtropical through to tropical. So our grazing is open range. cropping is broad acre. Whilst we have some irrigated pastures, most of it is not irrigated. We do horticulture and viticulture. Western Australia is really the powerhouse of the Australian economy at the moment. And in 20 years, we've had a mining boom that has really doubled Western Australia's economy. Most of these resources are exported to Japan, Korea, China, and India. So, since we have a strong industrial alignment with these countries, our universities have really turned their attention also to this zone, and we have a lot of engagement with universities in this zone. So Perth is a centre for a multi-industry expertise. It's vibrant, creative, productive. It's a knowledge economy. We're really about producing knowledge. And we want to be and are a hub for integrated research and innovation. So we have lots of companies there in mining resources and energy and in the agriculture sector as well. So many issues that also would be of interest to you in land and water management, rural economies, policy and development, food, health, etc. All of this means that there's exceptional experience opportunities for students, great collaborative opportunities for staff, and good career prospects for graduates who come and work with us. Perth is great. It is one of the world's most livable cities. Lots of nice beaches, great big parks, very relaxed living. So I'd just like to speak a little bit about our Faculty of Science to give you some ideas for what we do. So the Faculty of Science is a faculty that wants to make a difference, and it's got 5 general themes. One is around feeding the world, preventing, diagnosing and treating disease, furthering human knowledge to serve humanity, harnessing resources and energy for a sustainable future, and restoring balance to our natural environment. So those 5 themes are integrated themes across the Faculty of Science that put all the disciplines together. And maybe they relate to similar themes that you have at your university. So in feeding the world, you can see there are lots of different disciplines that work together on that particular theme, from fundamental science through to applied agriculture. And I'll just talk a little bit about crop science, which is one of our areas, and introduce you to one of our professors, Professor Willie Erskine. So he's responsible for a major project that we're working on in East Timor called the Seeds of Life program. So East Timor is a very impoverished nation, just north of Australia, and has at least 2 months of the year where they have no food production. And so we have been working on developing seeds that produce far greater yield, and then developing storage mechanisms so that they can actually grow more food than they can immediately eat, and then store enough food to survive during times with no crops, and indeed then develop a food industry so that they can trade food for other services. So for the first time, we're having people who can build enough resources that they can actually send their children to school and do things other than just sustaining life. So the diets are terribly inadequate, and as I said, they have hungry periods for 2 to 4 months each year. So the Seeds to Life program looks at long-term approaches to food sustainability and developing crops rather than importing them, and then training locals how to run those programs. We have Timorese agricultural science graduates at our university, and we are adopting various strategies to improve crop yield. These are some of the places we're working. So farmers have increased their household income, and this is really changing their lives dramatically. On the second theme of preventing and treating disease, we'll look at a couple of areas, biophysics and genetics. Next I'd like to introduce you to Professor Tim St. Pierre, who has done a lot of work in Thailand, by the way. He has many Thai collaborators. He is a biophysicist working in magnetic properties of iron. And he has looked at how to measure iron overload in the human body, particularly for the diagnosis of a disease called hemochromatosis. He's the winner of our 2010 Academy of Science and Technological Engineering Award for his work. So his work was to develop a new measuring technique for iron deposits in the liver. And he is using magnetic resonance imaging to magnetise iron in the body and the radio signals to monitor the presence of iron in tissues. This provides a repeatable, non-invasive, safe treatment. And his technology called FerryScan has now been commercialised. It began commercialisation in 1999 and is now used in over 20 countries with over 14,000 patient measurements. The second researcher is Professor Ryan Lister, one of our younger researchers, who's an expert in advanced DNA sequencing and computational biology. He's looking at complex biological systems, particularly those that impact biomedical and plant science. He's an expert in epigenetics. His Nature paper in 2011 was the most cited biology paper in the world. And it reports the first complete description of the epigenome of any cell. And he's really going on to do some fantastic work in this area. In furthering future knowledge, there are lots of areas that contribute to that idea, but I'd just like to look at one, astronomy, and show you how you can turn something that might look like a natural disadvantage into an advantage. So here I'll introduce you to Professor Peter Quinn, who is a highly respected radio astronomer. A couple of decades ago, the world's radio astronomers decided they'd like to build the biggest telescope on the planet, a square-kilometre array of radio telescope receivers. And radio telescope astronomy relies on being able to put your receivers somewhere where there are no other radio waves. So you have to find a very isolated part of the planet with hardly any humans, no mobile phones, no televisions, no roads, no anything to disrupt the radio signals. And what looked like a big disadvantage to us, living surrounded by desert, completely isolated, has turned out to be a tremendous advantage for astronomy. So we're looking at building the square-kilometre array in a part of Western Australia that's many hundreds of miles from Perth, and at our university we've established the International Centre for Radio Astronomy Research. The project will look at 150,000 million star systems and analyse 150,000 million galaxies. It will study the origins of the first stars and the evolution of galaxies, the formation of planets, and measure dark energy and Einstein's theory of general relativity. This sounds like very advanced and basic physics. But actually, why is the Australian government, and indeed the world government, supporting this project? Is because of the technological advances that this project will bring. In particular, the computational science that will be needed to deliver this are huge, and the world will have to develop what are called exascale computers to move to the next level of supercomputers. In the first day of operation of this new telescope, it will collect more knowledge than is currently available on the whole of the internet, just in the first 24 hours. It will be a huge project. I've talked about energy and minerals, and I just talked a little bit about geology. So we're creating sustainable cities by looking at energy development, paving new ways for smart cities, harnessing zero emissions using geothermal energy. So geothermal energy will be used for heating, cooling, desalination plants for water supply, and indeed we're using geothermal energy to cool the supercomputer that will be used in the radio astronomy project. In restoring balance to our natural environment, I'll look a little bit at marine science and introduce you to Professor Jessica Murray, who's one of our conservation and fisheries experts. Jessica, in fact, is passionate about sharks, marine animals in general, but particularly sharks, because I don't know if you've read in the press, but sharks are a bit of a problem in Western Australia. The government's decided to solve the problem by trying to kill sharks, and Jessica's very passionate about protecting sharks, so we have an interesting debate in our country. She's a conservation fellow in the Zoological Society of London. And the work is around monitoring fish numbers, analysing ecological and economic benefits of marine sanctuaries, and investigating the displacement of humpback whales. The sanctuaries that she's been responsible for creating will allow populations to recover and helps to protect aquaculture systems. So lots of work going on with fish all over the place. So I did say this would be a short presentation, just to give you a little overview of some of our work. I've only presented the science faculty, and I know many of you are from other faculties. If you have questions, I'd be very pleased to answer them. But I do hope that you will be encouraged to engage further with our university. Thank you very much.